All right, here we go. We're going to start the new chapter 6.1. I just wrote a polygon down. How many sides is that? Five. So it's a what? So it's a pentagon. All right. So what I'm going to do, I'm not really going to do a whole lot with the pentagon just yet, but I am going to do this. We're going to talk about a word that's going to be important. Here's the word. Let me write it down first before I draw it. It's called a diagonal, and you've heard that word before, but as far as geometry is concerned and on these shapes and polygons, a diagonal is something specific. You can start at any vertex. It doesn't matter what vertex you start. Okay, let's just start right here. And if I draw a line segment that connects this vertex to the, listen to the word they use, the non-consecutive vertices. Well, the consecutive would mean the one that's right next to it. So I'm not connecting from here to here, and I'm not connecting from here to here. I'm connecting to the non-consecutive vertices, which means I would connect from here down to there, go back to that same starting point, and connect to there. Do you see that? Those are diagonals right there. That's considered a diagonal, the two red lines. So if I start at any vertex and then I connect to here, that would be the diagonals of that particular polygon. So let's just stick with this for a second. I'll tell you what, let's do this. Let's kind of put this on hold. Let's group that together, make this a little bit smaller, and make it right there. And I'll copy and get rid of it. What I'm going to do is this. I am going to make some figures here. We'll make a triangle. And these don't have to be any particular shape, you know, like a isosceles or equilateral or anything like that. That's all I'm going to do. Now let's do another one that's 4 sides. And again, I'm going to, it doesn't have to be a rectangle, doesn't have to be a square. I'm just going to draw 4 sides. Okay? So there's 3, there's 4. The one that I drew earlier, I copied. We'll bring that up in a second. Okay. What I want to do is this. Would I be able to draw a diagonal on this triangle? If I started this vertex, would I be able to go to a non-consecutive vertex? No, because that one's consecutive and that one's consecutive. Do you see it? It's right next to it. So I can't really draw a diagonal with that. So let's get rid of that. But what I can do is, this is kind of a basic question, and you're going to say, well, of course, that's going to be true. Let me see what I want to say. Let's do this. Let's say we have 3 sides. Okay, and this is 4 sides, and we'll do the 5-sided one in a second. I'll tell you what, let's just do it now. Let's put it up here. And let's ungroup it. Let's get rid of this. Let's get rid of this. We'll do that in a second. Okay? And then this one is 5 sides. Grab that. I'll show you what we're doing here in a second. How many triangles do we have here? If I have 3 sides, how many triangles do I have? It's 1. Okay, it's not a trick question. Okay, I have 1 triangle right here. And I'll show you where we're going to go with this in a second. So I have 1 triangle. Now, what I'm going to do is I'm going to start drawing diagonals. I couldn't draw a diagonal here because I didn't have any non-consecutive vertices. But what if I drew some diagonals here? What if I started here? I don't draw to here. I don't draw to here. I can only draw how many diagonals on that? Just 1. Okay? But my point is this, is how many triangles? Say it. I got 2 triangles, right? I got 1 here and I got 2 here. So I have 2 triangles. Everybody with me? Let's do this one. We already drew those diagonals earlier, but I'm going to draw them again. So there's 1 diagonal, there's another diagonal. How many triangles did I just draw? 3. So I've got 1, 2, 3. So I have 3 triangles. You with me? If I had 6 sides, I'm not going to draw this. I think this is enough to get us started. If I have 6 sides, how many triangles do you think I would have? Look, I got, yes. Okay, watch. 3 sides, 1 triangle. 4 sides, 2 triangles. 5 sides, 3 triangles. What am I basically doing to the number of sides? I'm taking them, I'm adding 1. Well, if I start with the number of sides, how do I get to the triangles? I take 2 away, right? Okay, subtract 2 from each of those. So if I had, let's say, 7 sides, okay, then I would have how many triangles? I'd have 5 triangles. Okay, if I had 10 sides, I would have what? I'd have 8 triangles. Okay? What if I had n number of sides? Which means that could stand for anything. Say it, Jaden. N minus 2, right. So the number of triangles would be n minus 2 triangles. So if I had 1,000, what would it be? How many triangles? 998 triangles, exactly right. Now, why do I care about how many triangles in here? Because this is what I'm going to try to do. What I'm trying to do is figure out, listen to me, I'm trying to figure out the sum of the angles of a polygon. Now, what does that mean? I'm taking all the angles inside of here and doing what to them? Sum. Adding them all up. Okay, the sum means I'm going to add up, right? So I'm taking this angle, this angle, and this angle. I'm going to add them all up. Well, we already know what the sum of the angles of a triangle are. What are they? There's one triangle, so 1 times what? 180 degrees, right? So the sum of the angles of one triangle is 180 degrees. What if you had a four-sided figure? I want to, again, what am I trying to do? I'm trying to find this plus this plus this plus this. It doesn't matter what shape it is, as long as it's a four-sided polygon, a quadrilateral, I can figure out what all the angles add up to be. So let's see what we had. We had two triangles, so that would be 2 times what? 180, which is 360 degrees. Everybody with me? Okay, look at this, 5 sides. I want to add up all 5 sides. Now when I put these arcs here, it doesn't mean that those angles are equal to each other. I'm just showing you the angles, okay? So if I added up 1, 2, 3, 4, 5 of these angles, what's it going to all add up to be? It's going to be what? 3 times 180. I think that's what, 540? Is that right? Okay, does that make sense? So, what if I had 7 sides? What do? You take 2 away from it, right? And then you take 2 away from 7. So watch the math. I'm going to go 7 minus 2 times 180. Why do I go 7 minus 2? Because that shows me how many, what? How many triangles I have in that figure, okay, in that polygon. So, I don't know what this is off the top of my head. What's 5 times 180? Somebody do it. Who's got a calculator? Quick. 900? Okay. All right, 900 degrees. All right, you get the idea? So what if we had this? What if we had n number of sides? How would I find the sum of all the angles of a polygon with n number of sides? What did I do? Right, I went n minus 2, because that tells you how many triangles there are, then what? Times 180, because there are 180 degrees in each triangle. Agreed? So, depending on how many sides you have, you just take 2 away from it, multiply it by 180, and that's the sum of the angles of a polygon. Make sense? It's not too hard, is it? Okay. So that's the first thing that we're going to learn, and that's actually it's a theorem. It's Theorem 6.1. They call it the Polygon Interior Angles Sum. I'll write it down. Polygon. Now, good. Each book, uses different names. Some books don't even give it a name. This book, it seems like they like to give it names. Okay, so they call it the Polygon Interior Angles, I'll just shorthand it, angles sum. Now, we are just finding the interior angles, aren't we? Okay, that's all we're doing right here is finding all the interior angles of a polygon. And that's the name of the theorem right there. And this is the little formula right there in that box. Okay, the sum of the angles of the polygon, n minus 2 times 180. So, what if I gave you a problem? Let's try to squeeze this in. What if I had some crazy polygon like 17 sides? Who's got a calculator ready? So if I had 17 sides and I said to find the sum of all the angles of a polygon, what would you do? That's right. You go 15 times 180. And somebody give me that number. 2,700 even. Okay, good. What does that mean? That doesn't mean every angle is 2,700 degrees, does it? It means what? Add them all together. That's right. If I take the sum, if I add up all the angles and I had 17 sides, do they have to all be perfectly equal sides? No, they don't. Okay, like these weren't all equal sides or equal angles or anything. Okay, but I do know what they all add up to be. Are we listening? They all add up to be 2,700 degrees, and you could do that. You said 1,000 sides, right? So what would you do? What would the math be? I'm not going to do the math, but what is it? It's 998 times 180. All right, and that'll give you the sum of all the angles of a polygon that has 1,000 sides. All right, go ahead. You got it. Give it to me. What is it?
179, 640.
179 what?
640.
640. There you go. 179,640 degrees in a polygon that's got 1,000 sides. Okay? Make sense? All right, let's move on. Okay, we talked about just any old polygon. Okay, we didn't say anything about the lengths of the sides. We didn't say anything about each of the angles or anything else. But right here, this is more than just a regular this is more than just a ordinary polygon. It's kind of special actually, because this side is equal to this side. So all sides are equal. How many do we have? 6. Okay, so it's a hexagon. So I got 6 sides right here. If all those sides are equal, and two things have to be true. Now, when I write these arcs, that means these angles are equal to each other. I did a whole bunch of these arcs in the other one, but that did not mean the other ones were equal to each other. All these angles are equal. All these sides are equal. Whenever you have a situation, when you have a polygon, that all the sides are equal and all the angles are equal, we give that a special name, and we're going to do some stuff with these in a second. We call this a regular polygon. You're already familiar with one type of regular polygon. Let me scooch this over. I think I got one already drawn. This was a regular polygon. Do you remember this? Or we called it a what? If all these sides were equal to each other? It was equilateral, and if it was equilateral, it was also what? Equiangular. Okay, now that's on a triangle. If all the sides are equal to each other on a triangle, then all the angles will be equal to each other as well. On other polygons, just because all the sides are equal to each other does not mean necessarily that all the angles are going to be equal to each other. They may even have a, I don't know, it doesn't look like they do have an example in the book, but just believe me, okay? I just don't have enough time to show you this, but just believe me that just because all the sides are equal does not necessarily mean all the angles are going to be equal. But if it's given that all the sides and all the angles are equal to each other, then we call that thing a regular polygon. So let's just do this. What I can do now, realizing this is a regular polygon, realizing that all these angles are equal to each other, I can actually find each of these angles, each individual angle. Before we couldn't, because we didn't know all the angles were equal to each other. But now we know all the angles are equal to each other. I should be able to find each one of these angles right here. So first thing you do is you find the sum of all the angles. How do we do that? There's 6 sides, so we do what? 6. Talk to me. Help me out. Like I know what I know you know what you're doing. So it's going to be what? 4 times 180. And what's that? 720, is that right? So 4 times 180 is 720. What does that mean? Does that mean each of these angles is 720 degrees? Obviously not. The sum of all the angles are. But what did we say was true about all these angles? They're equal to each other. So what do you think we're going to do? That's right. They all add up to 720, don't they? We have 6. Now you can only divide by 6 if what's true about the angles. If they're all equal to each other. If they were all different measurements, you couldn't just divide by 6, could you? As long as it's all even, I can divide evenly by 6. And so what's that? 120, right? So guess what I just found? I found the measure of each of these angles in a hexagon. And what are they? 120 degrees. I'm not going to do that for all of them, but you get the idea. So every one of these angles will be 120 degrees. You could do that with any shape, couldn't you? I mean, again, if you had some crazy shape. Let's go with that 17 again. So 17 minus 2 times 180. And so what was that again? 2,700? Was that what it was? 15? Yeah, so it was 2,700. But what do you do, though? That's the sum of all the angles. If I want to find each individual angle in a 17-sided polygon, what would I do with that 2,700? By 15? 17, because there's 17 sides, right? So there's 17 angles. So I divide by 17. So that probably doesn't come out pretty, but what do you get there? Okay, 2,700 divided by 17. Just go one decimal place. 158 what? 0.8? Okay. So that's approximately each angle of a 17-sided figure, okay? If it's a regular polygon, all right? A regular polygon that's got 17 sides. Everybody see that? So you could do that with any shape, couldn't you? All right, or any number of sides. All right, let's move on to the next video, and we've got a little bit more.